session on ANSYS Workbench tutorials. In this session, we are going to analyze a connecting rod for buckling analysis. We will start by double-clicking on static structural. The material that is used for connecting rod can be chosen by clicking on engineering data sources, general materials. In the previous session, we have discussed about the material. One is aluminum alloy and the other is stainless steel. I'll go to project and update project. Next, I'll go to geometry and right click. Import geometry. I'll select the geometry. Next, I'll go to model and double click on it. Next, I'll go to geometry and change the material to aluminum alloy. I'll go to mesh and change the sizing to fine and update. Next, I'll go to static structural and insert fixed support on these two edges. This is the big end of the connecting rod. Now, on the small end of connecting rod, you can either give force or you can give some pressure value. So, I will insert pressure of say 16 megapascal. Next, I'll go to solution and insert deformation total. I also want to see the strain and the stress over the body. I'll solve. This is the total deformation that is obtained over the body. The highest value is 0.019 mm. Next is the strain. The value is 0.00118. The value is very small, which means that the change of shape is going to be very less, or the change of dimension as you say. Here what you see is actually a very exaggerated version. So it is very small a value, and the minimum value of strain is 1.17 into 10 raised to minus 14. Again, it's very, very small. Next, I'll go to equivalent stress, and you can see that the maximum stress generated over the body is 84.338 megapascal. You can just animate and check the result. This is by using aluminum alloy as the material. Suppose if I change the material to stainless steel and solve once again, let's check the results. Now you can see the deformation is 0.00699 mm. That is the highest value, which is very low. You can animate and check the result. The strain is further lesser as compared to aluminum alloy. It is 0.000437. This is the maximum value over the connecting rod. The equivalent stress that is generated is 84.35 megapascal. You can just animate and check it. This is as far as the static structural analysis is concerned for the connecting rod. Next, we will go back to the main window and we will choose Eigenvalue Buckling and drag and drop it over the analysis. I will now go to setup and double click on it. You can just go to the solution and solve it once again. For buckling analysis, you have to perform the static structure analysis before, and then only you can go for buckling analysis. You cannot do buckling analysis separately. So now we will go to analysis settings, and maximum modes that is given is 2 by default. I will change it to 3. Also, I will change this include negative load multiplier to no, as I do not want the negative load multipliers. Next, I'll go to solution, right click and insert deformation total. You can see here this is for the first mode. I have given 3 modes, so I will choose this again and change the mode type to 2. I will insert one mode and change the mode type to 3. Now I'll go to solution again and solve. We'll go to the first total deformation value that we have obtained. You can see here that the deformation is 1.0221 mm, that is maximum value of deformation. You should check the value of load multiplier, that is 65.278. Now, suppose if I give a load of 100 Newton on this body, then if you multiply 100 with 65.27, you would get 6527 Newton. At this value, whatever amount of deformation you see, you are right now seeing that. So that is the meaning of load multiplier. Now generally when you subject your body to 100 Newton, you would see a particular amount of deformation, but when you do buckling analysis, it means that your body will buckle in this way at a load which is to be multiplied with the load multiplier that is given to you. So when you multiply your applied load with this value, you would see a deformation of this sort. So basically you are keeping a factor of safety, and your body is going to be safe under that load, because it is supposed to be subjected to 6527 Newton, but you have only given 100 Newton as of now. So that's the meaning of load multiplier. So this is one value. Similarly, you should understand for the next two values. The next value is 226.09. That is a load multiplier. And you can see here the maximum deformation is 1 mm. And these are the rest of the deformations over the body. So what you see over here is your buckling. You can see it in a vertical fashion, because that's how your connecting rod is going to be. So this is how it is going to buckle under this condition, second mode. And for the third one, you would see a roll kind of motion over the body. The first three modes are generally yaw, roll and pitch over the body. So the maximum deformation at this point is 1.236 mm and the load multiplier is 227.28. So if you multiply your given load with this value, at that point you would see a deformation of this sort. So this is the value obtained using stainless steel. If you want to change the material and go to aluminum alloy, you can just change it once again. Come here and both will be solved together by clicking on solve. So let's see the deformation now. It is 1.0221 mm. You can just check on the load multiplier. It is 24.034. And when I animate, this is the way it is going to buckle. When you go for the deformation 2, your highest value of deformation is 1.221 mm and the load multiplier is 83.088. You can animate and check the result. And for deformation 3, the maximum value is 1 mm and the load multiplier is 83.468. So with the comparison of two materials, you will understand that the body will be much safer in buckling when you take stainless steel as a material, because the load multiplier value was more, which means it will take higher amount of load to buckle to that extent. But when you are taking aluminum alloy, the load multiplier value is smaller, which means at a very low value, your body will start buckling and showing this result. So you need to be careful while choosing the material. If given a choice, I would choose stainless steel as a material if cost is not a constraint, because the cost of stainless steel will be higher than cast iron. So if cost is not the criteria and safety is the criteria, then I would definitely go for stainless steel. So that's how you take two materials and compare it for a particular analysis. So with this, I end the session. I hope you have understood how to analyze a connecting rod for buckling analysis. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.